That should be recording. Okay, so let me work through that one just like I said in case they don't get here. Subtract 3. Tan squared theta equals negative 3. Oh, oops. You may have been right the first time. I didn't even catch that as a negative. I'm just going to go ahead and pretend it's plus 3, just because that was what we talked about. And then square root both sides. So tan theta equals plus or minus root 3, and then your handy-dandy unit circle. And again, if you use your hand, that it's, 30, 45, 60, 90, and 0, and that we flip our hand over, and it ends up being 60, and all the ones that go with that, which is 120, 240, and 300. I didn't even catch that. I'm betting I may have just copied the wrong problem to show the comparison. I'm betting that probably was no solution because we never do get negative root 3.
Yeah.
Yep. All right. Didn't even catch that.
I remember some from before. Wouldn't you have to complete this in some way or take out the cosines and
Yes.
select
Yes.
them?
GCF. Very good. There's only 2 pieces, so it's literally either GCF or it's going to have to be done by like a square root, and we can't do a square root on this because it's already square rooted.
Okay.
Very good.
So far, the possible answers are 90 and 270.
Okay.
Okay, so
We should have 2 more after that. Yep.
and then the next would it be 330? 330 and then 30.
Yeah, nice. Nice job. Okay, so yes, this absolutely has to be done by GCF. There's just no other way to do it when you only have 2 pieces, unless you're going to square root. Okay, so cosine x is your GCF, and you should have been left with that, and then equals 0, and then set each piece equal. And then go through the whole, basically, linear process on the second one. So it ends up being root 3 over 2, and you don't have to worry about the plus or minus because the square root's already there. And then, like same as before, on the unit circle, cosine is x. And, if you're doing the hand trick, cosine's on the top. And the only place to make cosine equal 0, right, in order to have it be on the top is basically that the 90 degrees has to get folded down because there's nothing left on top. So, and then the matching one has to be 270. And then for the root 3 over 2, that's pretty easy. Again, 2's in the palm. If we fold in the 30-degree finger, we have 3 left on top, so that's got to be your x. So 30 degrees, and then the matching one, since it's positive, has to be in the 4th quadrant. So yeah, it's a lot to remember because you do have to remember which quadrants it's positive and, all the different things, but, gotta do them. That was why that I will honestly say probably that unit, I was not really surprised that it was the toughest for a lot of people. It is a lot of stuff to remember when you're talking about solving. Okay.
notes from before on this
That's
one.
fine.
So after using Pythagorean identities,
Yep.
I got to 1 minus cosine squared x equals cosine squared x plus cosine x.
Okay, excellent.
Then I got to 1 equals 2 cosine squared plus cosine.
Okay, wait, 1 equals? Oh, okay, so you move this one over. I got you. Just making sure I'm keeping your steps up. All right. 2 cosine plus cosine equals 1. All right.
Then I took out the GCF, which is cosine. So cosine times 2 cosine plus 1.
Okay, there's only one problem with that. How many pieces does this have? How many terms, basically?
Wait, 1, 2. Oh, 3.
It's got 3. There's only one way you can deal with 3 terms. It's the dreaded F word. We must factor. Oh, yes, we must factor. Yeah, if you've got 3 and you've got squared in there, you don't have a choice. That's sum and product all over. Okay, and remember the good news is that you can factor it as if it was 2x squared plus x minus 1.
So just negative 2 over 1 in the x.
You got it. There's your product. There's your sum.
So then negative 1, negative 1. Wait, no. 2, negative 1.
Yeah, 2 negative 1. Sorry, I had to think about it for a minute. I'm like, wait, we're adding to get positive 1. Yeah, okay. If it was the other way around, if your product was 1 and your sum was negative 2, that would work. Yeah, but 2 and negative 1, yes. Okay, so you do grouping, right? You do grouping where you write it out horizontally and then put the parentheses around it?
Yeah.
Okay. So 2x squared plus 2x minus 1x plus, or minus 1. All right. And then group.
So from that, you would basically take out the 2 cosine x.
Yeah, because each x represents basically a cosine. So if I take a 2x out of that, it's like 2 cosine x. You got it? What's left?
X plus 1.
Mm-hmm. And then what do I need to take out of this one?
-1.
Mm-hmm. And then they match, and if they match, then we're good. That means we've actually set it up right. So you've got 2x minus 1 and x plus 1. Which is the same thing as 2 cosine x minus 1 and cosine x plus 1.
So the cosines would be -1 and then 1/2.
Yep, positive a half and negative 1. Good job. And then the last part where you actually have to go find them. That's definitely a multi-step trig problem.
Yes.
All right, slide that one down. Okay.
It would be 180, then 300,
Mm-hmm.
then 60.
Nice. Nice job. Very good. And again, using just playing with the hand trick, knowing that this finger is the one that's got to come in to make it a half, so it's 1/2. Yeah, the -1 is just hopefully one that people remember because axes, those the 1 0, -1 0, those points.
Do you think such a long one would be on the SAT?
Well, the problems that are on the SAT range in difficulty. You have ones that might take 30 seconds to do and ones that'll take 2 to 3 minutes to do. If they have one like this, it would be, there'd be like just one like that. And it would be considered one of those ones where it's an upper level question, so they expect it to take a little bit longer.
Okay.
The hope is, no, they want to make sure that you remember your unit circle and your basic equations, but should always prepare at least to see. Yeah. Okay, and probably not going to have one like this, just because this one does take even longer. This is that final bonus stuff we got to on this unit where you can't do anything with this unless you square it.
Yeah, you would square both sides?
Mm-hmm.
Okay.
Yeah, because there's no way to substitute. There's no way to do anything with it because there's nothing in common and absolutely nothing that helps.
Okay, so it would become sine x squared plus cosine x squared
Mm-hmm.
plus 2 sine x cosine x.
Mm-hmm. Good. Equals
1.
Okay. And you went ahead and regrouped it because you remember that those were 0 or 1 when you add them together?
Mm-hmm.
Nice. Okay. So I can basically just, I know that equals 1. Thanks to my Pythagorean identities. All right, now what? Do you recognize this piece?
that's the part I forgot.
Ah, that's a double angle. That's literally that is the formula for sine of 2x. So some angle doubled. Those are very easy to deal with because you ignore the 2 until you get your answer and then divide them in half. So you would subtract 1 from both sides. Okay. And basically just I'm rewriting it based on the fact that it is a double angle. So I have sine 2x equals 0. So where does sine x equal 0?
At 180 and 300. I mean 360.
180 and 360. Okay. Why are you being weird? There we go. 180 and 360 degrees. Okay. So all I have to do at that point is then divide both of my answers in half. Because that's all that means is that I doubled the angles and got that, so I have to half them back again.
So then it would become 90 and 180.
You got it. Very good. And that one I would seriously consider for like an accelerated pre-cal class just because you have to recognize the identity, then you have to recognize the double angle formula. It would be a really, really good question just to see, oh, okay, this isn't that bad to solve because it's based on 2 of my identities.
So for the 2 sine x cosine x, if it was 2 cosine x sine x, would it be a cosine double angle?
No. The order that this is written does not matter because it's all being multiplied. The double formulas for the cosine, remember, was cosine squared minus sine squared. That was the basic.
Oh.
And then using the Pythagorean identity, we ended up getting, oh heck, what was it? 2 cosine, my thing is being weird, 2, glitchy, not supposed to glitchy. There, oh goodness. Lagging, very bad. Okay, it was 2 cosine squared x, oh, I think was it plus 1 or 1 minus 1? 1 minus cosine squared minus 1. And then 1 minus 2 sine squared x were the 2 of them. Oh, what is wrong with this thing today? There we go. Those are the other 2 that we got just by like rewriting them. But that was the cosine formula. This was the only sine formula there was.
Okay.
Yeah, and the order that this one's written makes no difference. It's all being multiplied. It's sort of like when we were working with the law of cosines about how we had to divide like by that whole chunk. You could divide by it all at one time because it was all being multiplied anyway.
Okay.
Yep. Okay. I think we'll take a break. We'll do some actual law of sines and law of cosines problems. Are those big enough for you to see?
Yes.
Okay, because I can make them much, much bigger. I just don't know how big the screen is on your end.
Yeah, they're good size.
Okay. Okay, so how did you set up the first one?
Oh, I started with the one on the right.
Oh, you started with the hard one. Okay. What have you done so far?
So I have to draw it out to really process it.
That's fine.
So I have the top left angle being
Mhm.
51.
Correct. Very good.
The top right one is 30.
Mm-hmm.
And then to find out the middle length,
The
I'm
height,
using
yep.
sine 51 over 38 equals sine 39 over x.
Correct. Very good.
And that's what I'm doing right now.
Okay. Excellent.
So that length I got to equal 30.8.
Correct. Very good.
So now to find the next x, I would use sine 90 over x equals sine 60 over 30.8.
Okay, that works quite nicely.
Okay. So now and x is 35.6.
That was what I got. Very nice.
So now I'll do the next one.
Okay. Quick question. Do you remember your ratios for your special right triangles?
Do you mean like if it's like n squared or something like that, or do you mean
Like this is a 30, 60, 90. So the ratio is supposed to be short length, long length, hypotenuse. I just didn't know if you'd remembered that one. I don't know how much Schmidt or, oh Lord, brain fart, Miss Cockrum got into those. I remember when I went over them with y'all, some people were saying that they kind of remembered it. Some people were like, no, we never did that one at all.
this year was my first year
seeing that?
Yeah.
Okay. I'm saying if, and I think they actually give you these ratios on the formula sheet, if I'm not mistaken. If you get something like that, and this ends up being what it was, 30.8, right? You could actually, to get it to go to this length, you could actually divide by root 3 and then multiply by 2. And you'd get the same answer.
Okay.
Yep. Like I said, and I think those ratios are actually on the formula sheet for the SAT. But doing it this way, we had talked about it before where I said it's not wrong ever to do it using the law of sines because that was what y'all learned first because, you hadn't seen this. We already know the sine of 90 is 1. So that's the only reason that it actually works. But go ahead, set up the second one.
Okay.
What's up?
You don't see it?
What am I looking for? Oh, come closer. Let's see the sparkle.
It's not that much sparkle. Don't touch it.
I'm not. Where did you go to get it?
Carter Inc.
Savannah?
Nope. In town. It's where Trevor. Yeah. It's where Trevor, Amy, Andrew.
Got their family tattoos
Jess,
from?
yeah, all
Okay.
them got their stuff from.
All right. I don't think I put any money in your account for that.
Amanda paid for the actual piercing and I paid for the spray.
Spray?
The saline spray.
Got it. Okay.
And then, Ford's, Cindy ended up paying for our lunch, so I didn't have to.
Where'd you go?
We went to Olive Garden. I have my leftovers in my car. Because they give you, oh my god.
I know. I've been. It's been a while, but I've been.
And the breadsticks. Oh. Madison was going ham. It was so funny.
Are they? Is it real butter?
Mm-mm.
Oh, good. Then
No,
you're spared.
they're vegan.
Okay.
Spared.
She
was like, I'm trying to manifest them. The girl heard her and she's like, I got an order coming up for y'all, and she was like, oh She like was down in those breadsticks. I was like, oh my gosh, girl.
Hey.
But I said I'm gonna stop by the house and get some green juice. I actually have some veggies in my cistern.
Are you going back over to the
Yeah, I
bottles?
think we're gonna watch The Nightmare because we never got to last night. Is this for family or?
It's for Ben.
What is it?
Caitlin bought it.
Oh, that's really sweet of her. Is it just like a new board game to find?
Yeah, it's a Christmas present.
I heard they're out watching Christmas.
All right, what you got?
15.7.
That is exactly what I got. And you had to subtract for the third angle first?
Mm-hmm.
Yep. So the third angle being 65?
Yeah.
Right, okay, so sine 65 over x equals sine 44 over 12. Okie dokie.
Does she want me to wrap it?
You know, I'm probably sure she wouldn't object if you did. All right, let's see. All right, enough trig. Rational exponents. Oy, thank you, love you. Okay, good.
Day.
Maybe you can.
The whole day, what? What? Maybe you can.
Shame your sister because she didn't do any dishes either today.
Caitlin?
To top and bottom?
Just the top one for right now.
I mean,
Okay.
you didn't make any dishes, so.
Yeah, they did.
Well, then that's your.
That's
then
what I
say
said.
something. Be like, you're not a guest. Do you do
Bet
this?
me that I'm not going to.
Mm.
But they're
I didn't make any
they're at the
dishes.
bamboo garden in Savannah.
Botanical?
Yeah.
The light show?
Yeah.
Okay. I figured because I was talking to Courtney on Snapchat. She posted that they were gonna go see some Christmas lights.
Mhm.
So I was like, okay, well, I just got my nose did.
Did you show your dad?
I didn't know if he was up.
He's up. He's in the
Okay.
garage.
Is he a little out of it?
I think he's in the garage. Did you see when he came up?
There were lights, but the garage was closed.
Oh, he's probably got cold. He's not feeling good.
I bet. Did they do all of them or just the head?
All three.
Oh, jeez.
Okay, so these are not nearly as bad as people think, because I don't know, again, how much Miss Cockrum got into these when she was doing like rationals and radicals and all that kind of stuff. If you remember how a rational exponent works, the bottom, like on a plant, is always the root, and the top is always the power. So technically, that's the same thing as saying this.
Oh.
But here's the good news. If you think about it this way, if it helps you think about it this way, as far as what you would do to get rid of the cube root and get rid of the squared on both sides, because technically that's what you're doing, is you're trying to get rid of it. You can do this in one shot using a reciprocal, because of your exponent rule about how, like, if you have x to the 4th to the 3rd, that becomes x to the 12th, right? You're raising a power to a power. If you raise both sides to the 3/2 power, okay, that cancels. And again, you can think about this, if you like, as the square root of 64 to the 3rd power. And you know what the square root of 64 is. 8, and then you just multiply that to the 3rd power. 4, 8, 5, 12, I think.
Oh, wait a minute. So the thirds and 3/2, they cancel each other's out?
Yep, because if you raise a power to a power, you're multiplying them, right? And if you multiply 2/3 times 3/2, it goes bye-bye.
Okay.
Mm-hmm.
So then, yeah, 5/12.
5/12, okay. So yeah, so these aren't nearly as bad as people think. They just start panicking when they see fractions for some reason.
So then it'll be 507.
You got it.
So would you use the same rule for this one? You would multiply it by 4/3?
Okay, so let's multiply both sides by 4/3. We know we're going to have to do it twice because we have two different fractions with two different bases, but that works. Multiply by 4/3. And that's just going to give you 3x.
And that'll be 2/3.
Okay, so x to the 2/3. So instead of multiplying by a reciprocal at this point, because I only have one of them and I don't want to put like another fraction back on this thing, if I only multiply by the denominator. So raise both of them to the 3rd power.
So 27x cubed equals x squared.
Nice. Okay. And then take a look at what we've got. This is something that you can factor using GCF if you move everything over.
So, would I bring the x squared to the other side?
Yep.
So x squared times 27x minus 1.
You got it. Yeah, don't forget that minus 1. That's what a lot of people forget when they're taking that GCF out. Got to be careful on that one. All right. So equals 0. And set each piece equal to 0.
So then x equals 0 and x equals 1 over 27.
You got it. Nice. Very nice job. Couple other ways, as I said, depending on how you want to think about it. The way you did it as far as starting off by doing a reciprocal, hey, at least get one of them gone. Works perfectly well. Just like I said, just make sure that you don't do the second reciprocal because then you're going to end up with another fraction on the other side that's not going to help you. You could have also multiplied both of these. You could have raised both of these to the 4th power since you got to do the same thing to both sides, and it would have canceled both of your fractions at one time. And then you would have still ended up with 3x to the 3rd equals basically x squared. So you'd have still ended up at the same place. I've seen other people do, believe it or not, they move the x to the 1/2 over to the left, and then they take out a GCF of x to the 1/2 power. And I'm like, I'm not doing x to the 1/2. I mean, literally it would have ended up like times 3x to the 1/4 minus 1. And I'm like, I'm not even trying to deal with that as far as setting each of those equal to 0 because that's just yuck. Because this would literally be like you would add 1, divide by 3, and then you'd have to raise it to the 4th power. So you'd still end up with 1 over 27, but I'm like, I want to get rid of the fractions as fast as possible. Because, yeah, so that's just, yeah. Okay, so let's try that one. Very similar to the first one, but with a radically different answer.
So then I'll bring it 8 to 2/3.
Got it.
So that would basically mean cube root of 8 squared.
Yep, good.
Which would be 4.
Yeah, nice. Did you put that in the calculator or did you do that by yourself?
I did it in my head.
Nice. Okay, so you remember some of your cubes. That's good. That's very, very helpful. Saves a lot of time.
8 is all I know, though.
Oh, I'm betting you know 27.
Oh, 3.
And 125.
Oh, 5.
Yeah, so I said those are, if you can remember the first 5 or 6, it really does help a lot as far as perfect cubes. Now you can do the higher roots even with an exponent on the inside, and as long as it comes out as a whole number, calculator will do it. Love you. Have a good time. I've been checking on him. Trust me, I'm the reason he's drinking Gatorade and eating crackers. Yeah. All right. So. All right. We got some nice applied, thoughtful process, but might actually give you a brain break for a little bit.
So B,
Okay. Why?
because it couldn't be 3 point. It couldn't be 3.25 times 150. So I don't know where D came from with the x over 12.
Okay.
1.5x. That basically just means
$1.50 per dozen, which doesn't help. Yep. So we know it's not that one.
Mhm.
Okay.
So wait, actually,
What's wrong with B?
yeah,
No, no. Did you just catch it? What's wrong with B? This is perfect as far as, yes, you have to take off the cost per dozen of how much it is to make them. What's the problem with this statement right here?
It would be a dozen times 150.
Right, which means at that, well, I mean, that's fine. They're $1.50 each that she's selling them for, but there's no X on here.
Yeah.
Yeah. So there has to be some way of incorporating an X in there. Otherwise, you've sold 1 dozen, but you've made however many you've made.
So it would be C.
It would be C, yes. You got it. Yeah, see the reason they have X over 12 is because for some reason you might fool somebody into thinking that it's $3.25 per cupcake. Dozen divided by 12. Yeah, which would be very bad because she really wouldn't, make a whole lot at that point. So, but yeah, has to be C because we have to incorporate the dozen into both statements, the profit and the payout. Good. I'm glad you caught yourself on that one. That was why I was like, I heard that and I was like, okay, tell me what's wrong with it.
Yeah.
Yep. Alrighty.
It could be anywhere between negative 3.6 and 26. Or do you want me to actually solve for M?
Okay, so how did you get that?
So, like from the rule that I gave,
Mm-hmm.
it has to be equal to or more than 0.375, which is 0.4.
Negative
has
point,
to
negative 0.375, right?
Yeah.
Yeah. Okay, so you went ahead and made it into a decimal.
Yeah.
That's fine.
But it has to be less than or equal to 7. So I chose those two numbers since the least it could be is the negative 3.75, and then 0.375, and then 7. Put both of them into the equation,
Mm-hmm.
and that's how I got to that. It
Mm-hmm.
can't be less than negative 3.6, but it can't be more than 26.
Interesting. Okay. That's a way to think about it. And if you stay between these two items, you're probably going to stay safe anyway. 4m minus 2, the only problem with this is there's really no way to get 4m minus 2 from this. If there was a way to make this be 4m minus 2, well, actually there is. If you were to multiply the whole equation by 8, right, if you were to multiply the whole equation by 8, you would get negative 3 less than or equal to negative 4m plus 64 less than or equal to 56. All right. And then I want it to be 4m minus 2. So I'm going to change this sign because I want it to be positive. So flip everything around. That's just literally multiplying everything by negative 1, which means I flip the inequality back around. If I added 62 to both sides, that's going to get me... So what you had originally works because it does say what is a possible value. It was not a multiple choice question. It was literally done as an open response where you would actually just put in a number. So you sticking between the what was it, something in 26?
Yeah.
Yeah, you're still good. You're still absolutely gold as far as you're in that range still. Now, if they wanted it as a multiple choice where they gave you what are the possible values, like what's the range of values, then you'd have to go through and you'd actually probably want to solve for m and then plug it back in.
Okay.
Yep.
So if I would solve for n, would I yeah,
okay.
would I use either part to solve for it? Like I could do 6 equals 4 minus 2 or 4 minus 2 equals 65?
Yep. Or, going back to the original one, me personally, just this is a little bit prettier to deal with. M over negative 2 plus 8 less than or equal to 7, subtract 8, less than or equal to negative 1. Yeah, okay. M greater than or equal to 2. So m has to be bigger than 2. Okay. So getting the smallest number, 4 times 2, 8 minus 2, your smallest possible would be 6. Okay. You'd have to solve the other way to get the biggest possible.
All right.
Yeah. Which in that case...
so many calling.
Multiply by negative 2. M would have to be, oh boy, less than or equal to, yuck. Positive 3/4. Yeah, wow, okay. Wow, yuck. So yeah, definitely would not want to go with the double fraction on that one, but yeah.
Huh.
Mm-hmm.
Okay.
Yep.
Yeah, that one was a lot.
Yeah, that one was a bit. Like I said, for me, I would try to get the middle piece to look like that if I can. By just doing algebra, because then if I get the middle piece and I'm doing the same thing to like all 3 pieces, all 3 things, then I know whatever it's between is going to have to be where my range of values is.
Okay.
Yep. Okay. Boop.